Yeah. Such a वही हुआ ना, and then बात वही है कि if you do make, let's say, a sheet, couple of sheet, and it does gets popular. By the way, we are live. So if you do make sheets and then it does gets popular, so usually these big firms, they internally have a page in which they know that this one is getting very popular. So for this specific role, we will not ask this question, or you know like that. Yeah, we are live. Hello, everyone. I'm Sahil. I'm here with Mukund today. So, this is about live DSA solving question, the interview that we'll be taking today with Mukund. Mukund, feel free to introduce yourself. This is your second interview, man. You might. We do a live coding session here on on coding and system designs. Please follow us for the same. And everyone who is watching us live right now, please feel free to keep on asking your questions in the chat, and we'll try to answer your questions. Cool. So Mukund, I think we should get started. So, so this is your first question.
We have a niche from AI to BI and AI to AI.
Yes.
Both are bidirectional. This is between the highest node of the tree, all other nodes. Okay, so I assume the question is asking if we have a tree. Okay, so like if we have a tree, and for let's say answer of I, sum of then from highest node to all other nodes. Is that right?
Yep.
Okay, so let's say if we have a tree, something like this. By the way, we don't have any self loop or anything as such, right?
Yeah.
Okay, and it is kind of connected, so it is basically it will be something like this. We have one. We have here. Let me just ease the is a bit more. Let's say we have another node here. Let me name. We mark this node as 4 and this node as 5. Because this one has 7. Okay, so now if we were to calculate answer of 1,
Yeah.
it will be distance. I'm denoting this by I mean distance. I've abbreviated basically with this from 1 to 2 distance. Oh, okay. So basically it's okay. So 1 to 2, 1 to 3, and then 1 to 4 plus 1 to 5, and then again like this. That's that right?
Yes. So
Okay.
I
Okay, fine.
do have like one formal example for you. You can take this one as an standard and output that you can.
Okay, okay. Okay, so fine. It's the same thing which I have
Yes.
denoted here.
Yes.
Okay, so we have got the okay. So nodes are starting from zero. I have taken here as one.
Yeah.
Okay, so we'll have to take it as zero.
Yeah.
Okay, no issues there. So we have calculated this answer for one. So we can do this by using a single DFS, and for that we'll require O of n time and O of one space because we are showing only one variable here, answer one. But we have to calculate answer of I for all the nodes from 0 to n minus
Okay.
1. Okay.
Okay.
So
So Mukund,
how
like
about
before,
we?
I'm so sorry to interrupt you, but before, let's say we move forward, can you explain your understanding of the question once, like in a very simple term, so that then we can take it forward in that case?
Okay. So the thing is, this question is basically asking us to do a DFS from every node, something of that sort. Like from in basic terms, we can say if we run a DFS from one
Mm-hmm.
or maybe DFS, it doesn't matter right now. But if we are at one,
Yeah.
then we'll have to take the distances from one to all the other nodes and then take the sum of it. And
Okay.
then we'll have to do the same thing to every other node as well. This means we will be doing a traversal multiple times on all the nodes. So if let's say I am going for a simple DFS,
Yeah.
I'll write it here approaches. So I'll write it DFS at every node. Okay. So we can do a DFS at every node, like let's say DFS at one, and then at every node I'll mark the depth.
Okay. So you mean like you'll do DFS from, say, when you have a connection given as 1 to 2, so that is one performed from 1 to 2, and then let's say 1 to 3 is also given, so you'll do on the same way, right?
Yeah, so I'll write that over here.
Yeah.
Okay, so when I start the DFS at one, when I will reach, okay, well, I guess DFS is also fine, but I will be using DFS as the code is much shorter and easy to understand. So, okay, so
You'll be using what?
DFS.
Yeah, okay.
Depth first search. Okay, so basically we are finding depth. So I mean, yeah, so depth first search would be much more preferable and much more easy and much more simpler to code.
Okay.
So when I run DFS at one,
Yeah.
the depth of that node is 0. When I reach 2,
Yeah.
the depth become 1, and at 3 also the depth will be 1.
Yeah.
And when I reach, let's say when I reach at either of these 4 nodes, the depth will be 2. So it's basically at 1, the answer will be 0 into 1 because one node is there having 0 depth and two nodes having 1 depth.
Yeah. I think like you can come into the same time. Yeah.
Yeah. 4 nodes, which are 4, 5, 6, 7, having 2 depth.
Mm-hmm.
So this will be giving us 4 into 2, 8, 2, 10. Can you confirm if this is the correct answer?
Yeah, I think so.
Yeah, it's
So because
one. Oh, yeah. Okay, so then will be the answer here. So as we can see, we ran a DFS at this node, so we got answer of 1. But how about we do a DFS at every node in a similar fashion? So this will one DFS is taking O of n because at every node we are marking all the other nodes at least once.
exactly.
So it is taking O of n.
Yeah.
So but the issue is we are doing it at every node. It will take n square time complexity because every node will be visited twice, at least twice.
Yes. So what
And complexity will be open.
Mukund is trying to say is that when you do a simple one DFS for one time, you do it in just one term. But if when you move down to the one path, that path is kind of like already traversed once and will be traversing it again, which will increase the complexity that we do have, and then it can lead to worst case of n square, uh, since it's a possibility that it can be traversed again and again for each and every time I'm parsing out the tree.
Basically, I would like to add few of my comments on top
Sure.
of that.
Sure.
Like for instance, if I did a DFS at 1,
Yeah.
I was visiting 1, 2, 3, 4, 5, 6, 7. And when I do DFS at 2, I'll be visiting 1, 2, 3, 4, 5, 6, 7. So similar fashion, if I have n nodes, DFS at nth node, I'll be visiting the same thing 1, 2, 3, 4, 5, 6, 7. This means if we add all these, so it is basically n into n. So the time complexity in layman's term, we can say, not even exactly the time complexity will be O of n, but we can find out using this technique sometimes. So yeah, so I'm sure the time complexity will be O of n square.
Yeah.
And now I want to confirm how many nodes will there be.
Okay, so you can expect maximum number of nodes as like 3 into 10 to the power 4.
Okay, so max nodes. Okay, so
Like starting from 1, we'll be having at least 1 as the root node. And yeah.
okay, yeah, so 3 E4. So this will obviously give PL.
Yes.
So now we can make use of a technique, a very famous technique.
So just
Which
one more small deviation I'd like to take from a minute. So reason why Mukund asked me that what is the maximum size is so that he can understand that whether the proposed solution that he has provided will be working or not. So right, Mukund? So because of basis
yeah,
of that, you can approximate. Let's say that if you have a recursive solution and your input is quite big like this, you know that it will not be an optimal solution, or you can make it better. So that is a good point to ask during an interview. Go on,
okay,
Mukund.
so one more thing I would like to add
Yeah.
is for, let's say, in questions we have the, like, we will be given time limit is 1 second or 0.5 seconds depending on what problem it is. Usually, if like for instance, if I have 3 E4 and time complexity is n square, so I'll take the largest value of n, which is 3 E4.
Yes.
3 E4 into, again I will do 3 E4 because it is n square. The value comes out to be O of how much is it? 3 into 3 is 9. 9E8.
Yes.
Okay, so this is 9E8. But the issue is, in 1 second, we can expect only O of 1E8 operation, or at max somehow we might be able to get away with O of 2E8 depending on whether we are using C++ 17 or 20.
This is an awesome insight.
So this will, yeah, so this is for sure giving us a PLE in this case, because it is 9E8, it's not 1E8 or 2E8,
Okay.
directly 9E8. So of course it will give us a TLE.
Yeah.
I'll get away with this. Now, let's say we have, okay, so I'll just comment. Can I remove all these from
Sure.
here?
Sure. It's
But wait a second, I will copy down the details. I'll be using the same again.
Yeah. It's your canvas, man. Use it.
Yeah, true. Yeah, yeah. So, okay, so if we look carefully, answer of one was this. And by the way, I had mentioned we are marking the depth. So for answer, let's say answer of 1. By the way, I am taking 1. Okay, so like in the question it's asking 0, but since I had already drawn 1,
Yeah.
so please assume it to be 0.
It's fine. Yeah.
Just assume it to be 0 index. Okay, yeah.
Yeah.
Okay, so I'm assuming this array to be from starting from 1 index. Okay, not from 0.
Okay.
So since I had skipped the 0 thing, so okay, so at 1 I had marked 0, at 2 1, at 3 it's 1, At 4 it becomes 2. At 5 it becomes 2. 6 it becomes 2.
Two,
And
two.
7 it becomes 2.
Yeah.
Now how about I start my DFS at 2? Now if we look carefully and very carefully, if we are at 2, the nodes which are above 2, which are 1, and the children of 1 apart from 2, which are 3, 6, and 7, they became plus 1 distance further from 2. Okay, so I'll write it down here so it becomes much more clearer.
Yeah.
Okay, so 1 became 1 distance more. Since we know we came from 1 and 1 became 1 distance more, this
Okay.
means that those nodes which were at 2 or which were at 1 from 1 node, they will become plus 1 of that. This means it is already 0 and now will become 2 because at answer of 1 it was 1, and since I am going down from 1 to 2, this means the node which was the child of 1, which is not 2, its distance will increase by 1. Okay, so it was 1, 2, 3, again 4. Now, since we know 4 is a child of 2, not a direct child of 1,
Yeah.
means its distance will decrease by 1.
So, quickly, how are you thinking that you'll determine that whether this guy is a child by using the edges
Okay.
that has been provided?
No, I will use the subtree concept because it will be much easier to visualize it as a subtree. Because if we dissect this tree
Yeah.
into two components, which is one component will be 2, 4, and 5. One component will be 1, 3, 6, and 7. Okay. So if I just see this component, and I know that whenever I run a DFS, I am coming down from the top to the bottom side. From 1, if I go down to 2, this means this component 1, 6, 7, that component size will be like the distance of all the nodes here will become plus 1.
Okay.
And all the components which are a subtree of 2, their their depth will decrease by 1 because
Okay.
they were initially taken from 1.
Considering the approach of subtree, will it change your time complexity, or will it affect any way in your time complexity or parsing?
Yeah, because we are pre-computing the subtree beforehand.
Okay.
So because the tree is not changing every time, so it will be kept static in the beginning. And yeah, till the program ends, it will be unchanged. The tree will be unchanged, so we don't have to change it again and again. So we might get we can get away with pre-computation of subtree size.
Got it.
Okay, so I'll complete this approach
Sure.
first. I'll give the answer of for E4 and 5 as well, so it becomes much more clearer.
Yeah.
So
Sure.
answer to this is what 1, 2, 3. Okay, so 5 is also in subtree of 2, so its size will also decrease. And now coming to 6 and 7. 6 and 7, so we can see it's, those two are not in the subtree of 2. Their sizes will increase by 1. So 2 plus 1 is 3, and again 2 plus 1 is 3. I'm taking the previous value from answer of 1, adding plus 1 here, as
Yes.
you can see,
Yes.
from top to bottom.
Yes.
Okay, now answer of 2. Now how about I do an answer of 3, but this I'm just marking for reference just to visualize the concept, because the DFS won't be traveling like this in it won't be traveling like this.
That's
It
true.
will first explore all the depth.
Exactly.
I'm just doing answer of 3 for better understanding.
Sure.
Since we came from 1 down to 3, we will be using the subtree size of the depth, the pre-computed depth from answer of 1, which is this. Now since from 1 we came down to 3, this means that using the same concept which I mentioned above, if we
Yeah.
are in the subtree of 3,
Yeah.
our sizes will decrease. I mean the depth will decrease. Answer of 3, so first one is 1, So here it was 0. Now 1 is not in the subtree of 3. So its the distance will increase by 1. So it is 0 plus 1. Now 2. 2 is not in the subtree. So 2 was 1 here.
Yeah.
So it will become here. 4 now coming to 3. 3 is already 0. Now coming to 4. If 4 is not in the subtree, its size will again increase. 5 is also not in the subtree, so its distance will increase by 3. Now this comes there is one interesting thing to note here. Since 6 and 7 both are in the subtree of 3, this means their sizes will decrease
By 1. Yeah.
by 1 because I am considering the edge to be one distance. Is that correct or
No, that is correct. Yeah.
can we? So I initially assumed it to be 1.
Yeah.
Okay, so yeah, so this is basically taking use of this value and computing the current value, which is a very well-known technique called dynamic programming.
Mm-hmm.
So abbreviated as DP, many people like to call it dynamic programming. Sounds more fancy. So okay, so now we can use the same concept to compute our answer. So I will be okay. So what would be the function name? Okay, so we are running the function, right? And what will be the function name? Can I take anything, or
Yeah.
do you suggest any?
No, it's fine. You take it by yourself. Anything is fine.
I am writing solve as
Yeah.
the function name, and what will I be given? A tree.
So you'll be given like the n value, that is the number of nodes, and you can expect a two-dimensional array which will be giving you the edges input, which tells you that this specific guy is connected to this specific one.
Okay, so we are given an
yeah, rather than like a standard tree,
pair.
you are given more of like in the sense of how edges are provided. Yeah.
Okay.
In graphs.
Okay, so I'll be changing the graph. Okay. So we are given the edges. I will be making graph out of it. Okay, so we are given from 0 to n minus 1.
You can expect this to be a simple vector of vectors. So, or if you wish to handle it in pair, yeah, anything else.
It's fine. So I'm considering. Okay, so I have here made a graph adjacency list. So since we were given edges, I'm making a graph out of it. So now I need a visited array, and now I will need a DFS. I will call the DFS as 0. Nodes are 0. So nodes are starting from 0. I'll be passing adjacency list and visited array to DFS, and I'll be calling DFS here, taking a node.
Yeah. Just one small thing, Mugun. Can you please like keep on writing down a little bit more comments? For example, let's say that in line 74, you say that what is your intention to do in the next 3 lines, and then we move it forward that way.
Okay, sure.
Perfect. Thanks, man.
I'll be running a DFS at this point. And first, let's see what is the need of calculating, what is the need of marking, like calling the DFS function for. Since I mentioned here, I'll be calculating the depth at every node. So first, I am calling this at node 0. I'll be calling depth function, or like I'll be calculating the depth at node 0. I have mentioned here 1, so don't, I mean, not for confusion, I mentioned it again.
Yeah.
So, okay, so we'll need a depth placeholder as well. So I have written depth and passing depth here, so I'll have to change it here as well. Now, I'll be marking the node as visited since we entered the DFS function. if the node is not visited, if the child node exploring the child, if the child node is not visited, I'll run a DFS at that. Now comes the part where we have to calculate the depth. If we, yes, since the vector initializes the depth from zero, like for all the values, the depth will be zero. So we don't have to explicitly mention that node zero will be having zero. So we can say here depth of I, depth of node plus one, since we are getting the depth of the parent. And for us, the depth of the parent will, for us, the depth will be depth of parent plus one, since we are going down.
Yeah. Okay.
I'm calling the EFS from zero, so it will explode downwards. So considering from one, like I'm considering from zeroth node,
Okay.
the sentinel node.
Okay. Yeah.
So this will calculate the depth. Okay. Now comes the part where we'll have to use summation to get the answer. So for answer of one, this is the depth array, and since I mentioned here, yeah, since I mentioned here, at answer of zero, this is this all the values will be depth. This means what we got here from this DFS call have to sum all the depth values.
Can you, like, if it's possible, can you take down that computation lines that you have done in around like line 77 or something, so that we don't need to.
Okay, sure. Okay,
So you computed out the depths.
So here, if we were to run a brute force from int I is equal to 0 to I n minus 1, then we will have to call the DFS again and again, and I will have to mark the visited to be, again we'll have to mark the visited to be 0.
Reset and then mark it again, right?
Yeah, it's basically resetting visited and depth, and then taking answer of I to be accumulation of all the values inside of depth. But we can bypass this, since I mentioned it's taking the use of its parent's answer. So let me just get the placeholder for answer.
Okay.
Okay, so answer of 0 will be okay. Now comes the interesting part. Since we can have 4 nodes, so this means, okay, so just to avoid any overflows, I will, just to be safer, on the safer side, I will use long here, because I think it might get overflow.
Yeah.
So I am using a long, and I'm also changing in the return type. Also, this function will basically does what it says. It will sum up all values inside depth vector.
Yeah.
I'm using the inbuilt function. It's basically iterating over all the values inside the depth.
Yes, same as like a simple for loop. Yeah. Got it.
Yeah, exactly.
And
Okay,
this is
so
the
now
good
we are
practice
done with
that
this.
you have converted into a long, considering that there can be possibility that it overflows the answers.
By the way, I would like to mention one more thing.
Yeah.
Is we have to mention the long variable here also, because it is a constructor. If we pass 0, it will take it as int, and in locally it will try to use an int placeholder for this. So internally it might get overflown.
Yeah.
So I'm using it using LL here, just to tell it explicitly to use long variable type.
Perfect.
And since I mentioned that we'll be using the parent's value, so since we already got parent value using one DSS.
Yeah, you mean like this specific line, right?
Yeah, exactly.
Yeah.
And then adding it. So since one of the process is done, now coming to the step two, they have to iterate through all the nodes. Now comes the good part, which is iterating over all the nodes and trying to optimize the solution from n squared to maybe n log n or n. We'll have to see after the overall the function, how it goes.
Sure.
So I will clear out the visited and depth.
So, are
Okay.
you like writing it as a brute force and then afterwards you'll be optimizing it?
Yeah, I had already shown you the brute force method wherein we were explicitly calling the DFS
Each and
at
every time,
every
right?
node.
Yes. Yes.
Yeah. Basically, I instead of declaring a visited to vector, I have already declared visited for the second DFS. So I will clear it out because I'll be running a second time DFS.
Yes.
It will be another function. By the way, I have mentioned it here.
Yeah, exactly. That's fine.
Okay. So now we can go to this tree and look very carefully. Since we know the edges will be contributing one, this means if let's say I am at one, this means at one's left, which is 2, 4, and 5, everyone will be contributing 1 distance. This means it will be contributing their subtree size multiplied by the depth. Okay, so I will explain. Okay, wait a second. I will need a subtree vector because I mentioned I will be taking the subtree sizes as well.
Hmm?
I think I will use underscore, not camel case style, subtree size. And I'll need to make changes in the previous DFS as well. Instead of running again a DFS, I will need the previous DFS.
Yeah.
Okay, so subtree size will have to change. Okay. So since we are calculating the subtree size, so initially if we enter any node, the subtree size of that node will be 1.
Mm-hmm.
And whenever we are leaving that subtree, let's say when the DFS is finished, only then we will know how many nodes it totally had. I am not assigning before DFS, I have to assign it after DFS.
But aren't you considering this as a graph structure? So there's a possibility that it can go towards the parent node.
So this will be a tree for sure because we are given that nodes will be the edges will be n minus 1.
Yeah.
So that won't be an issue here.
Um. Okay. Okay.
So I'll go through this part again. Subtree size of node plus is equal to subtree size of I. So basically, if I am at node 1, so since we are currently taking into consideration the subtree size from the current node, that's
Uh,
why I have written here is equal to 1.
I was thinking because of this, like I'm not saying that they would be connected or it will be a cycle or something like that. I'm just having a small doubt. Let's say that you're standing on two. Uh,
Okay.
does two also knows that I can go to one according to the code that you have written? In that specific
No,
case,
it won't.
okay.
Yeah, sure. I'll explain because I have already marked visited. So
Yeah.
if I came from 1 to 2, the
Yeah.
visited at 1 is false. So this won't execute and we won't be able to go through go to 1 again. We won't be visiting 1 again.
Okay. Okay. Yeah. I was having just this out because you were adding it in line 76. Considering that is size will be increased. So yeah. Go on, please.
Okay, so shall I explain you the 76th line as well, or shall I continue with the approach?
I think like if you can like briefly explain it to me
Yeah,
once. Yeah.
sure. I'll go through. I'll basically dry run at one node. Let's say I am at node one. Since we will be considering one into consideration for the subtree size as well, because it's itself like we have to calculate the node itself as well in the subtree size. So if we knew all these subtree sizes of all the descendants of one, then how about I add all their answers to one? Hmm? That way we will be getting all the subtree sizes. This is basically doing subtree size is equal to 1. When we enter the DFS,
Yeah.
we are marking it 1. Here in the tree, I'll mark 1. At every node, it will become 1.
Mm-hmm.
Okay. When we go, when we finish the recursion, then we will mark parent, which will be node here.
Yeah.
This is node, and this is the children.
Yeah.
This I is the child. So child is currently let's say 7, and parent is 3. So this will contribute plus 1 to 3.
Perfect. Got it.
Means its answer is basically, child is giving answer to its parent. We are calculating the summation of all the children inside of it plus 1.
Yes.
Plus 1 because of this line.
Yes.
Because we will have to consider that node as well into our subtree.
Yeah.
So we got the subtree side.
Perfect. Yeah, that explains it.
I'll be sure. Okay, so I'll be calling the DFS2 method, which is another DFS function.
Mm-hmm.
Will accept the similar arguments, parameters. This is depth. If we don't require any either of these mentioned, then we will have to remove them. So if they are needed or not. Okay, so I have cleared the. Okay, so before calling DFS2, I have already cleared the visitors. Now I think we are good to go. Okay, so now coming to the second part of the. Are you trying to clean the code?
No. The line was going a little bit out.
Oh, okay, fine. One second. I'll shorten it a bit.
No, it's fine. It's totally fine now.
Fine, right?
Yeah.
Oh, okay. Okay, so now I am in DFS2. So since I mentioned in the workflow, if we are at 1, we are going down to 2. We are basically running a DFS. I will mark the visit of node plus plus. We have visited this node from 1 to 2. Now I am at 2. Since I know that I am a child of my parent, this means the total answer which was contributed, I will have to reduce the subtree size of mine.
That's true. Yeah.
Because because since I mentioned here in the I am at 2, then I'll have to consider myself as well in the subtree size.
Yes.
So 3 the subtree size. This means that answer of 1, if I had already calculated answer of 1, from that answer, if I subtract -3, then I'll be sorted out with half of the part, and the remaining part I will have to increase plus 1, which is the n minus subtree size of 2.
Yeah.
Because we know the 3 will be connected. If this is 3, then this will be n minus 3. Right?
Yeah.
So I will run a DFS here.
I believe like this is the most interesting part of the question.
Yeah, exactly. Because this this requires a bit of mathematics also, because let's say, okay, fine, we will be requiring, okay, using a local variable n to be reduced to this. Okay, let me try putting it down here. Okay, now we will have to get one more thing here before writing the logic because we need to update the answer as well every
Mhm.
node. So I'll have to call the answer as well. I'll have to change it here.
Okay, correct. So each time
Yeah.
you do
Okay.
pre-compute,
And
you'll call your actual DFS function again and then update answers directly from here. Perfect.
okay. So in parent answer. So basically parent answer is the answer of node we have already calculated. Since we are running DFS from zero, parent's answer is already calculated. So answer of node, okay, I am right now at 2. So I know that I am going down from the DFS call. I'm currently going downwards. So I will have to add the subtree size of current node.
Hmm?
So right current answer will be parent's answer. Okay, now I'll have to reduce our subtree size, which will be current answer minus subtree size of I. Okay, first part is handled. Now the second part, this component, because I am basically dissecting the tree into two components. At ith node, where the DFS all current
Is currently
DFS current
standing.
stack is. Yeah, exactly. So what is here? Okay, current answer will be adding plus. So this will be total nodes minus subtree size of I minus I. This will give us the updated answer. So we'll have to update the answer of current answer and then do a DFS2 of then function visited and then depth of tree size and answer. So one thing I noticed here is this depth function, this depth parameter, it's not necessary because we don't have to use it. So I'll remove it from here. Okay, now, yeah. So I think this will give us the answer.
Okay.
Or
Uh, can you emphasize a little bit more on line number 90 and 91? And maybe
yeah, sure,
try to, write down 1, 2 comments on example how you're computing it.
sure. Okay, so we can actually try to, if we look, we try to add, if we try adding these two lines based on mathematics concept, if we try to uh, shorten the line, control going upwards, scrolling downwards, we look closely, we are subtracting minus subtree of size and minus subtree of size again. Instead of this line, how about I do something like this? The same thing, right? So I I did it in one line. So basically, current. Okay, so instead of writing comments, is it fine if I explain it to you because it's the writing comment it won't be as good as explaining.
Sure, go on. Explain it to me.
And I am dissecting the tree into two components.
That's
If
true.
I were two, at node 2, we'll dissect the tree from 2 itself to the subtree, which is 2, 4, 5, and the remaining part. So I'm basically detaching the tree like this. Uh, I'm basically detaching the tree like this.
Yeah.
So one part is this, and the other part is the remaining thing. 1, 3, 6, 7.
Yeah.
Yes. So now, if we look closely here, now we know how many nodes are there in this subtree. This subtree size, which we already calculated using the DSS1 function.
Mm.
Yes, line number 83.
Yeah.
You know cases goes from top to bottom in a depth searching manner. So I were at one, I go to two, then this means I'm dissecting from two. So it will be dissected from the tree into two components, 4, 5, which is 1, 3, 6, 7. And now I want to, if I'm going down, this means I can store the parent's answer in current in some random variable in locally, which I declared here
Yeah.
in current answer. Parent answer. I'm taking the parent answer because from top we came down to this bottom part means we will have to decrease -1 from all the nodes which are in my subtree
Mm-hmm.
into subtree. Look here. For the remaining nodes, we will have to increase it because our current iterator is at 2. So from 2, the other nodes are one step away, but at 4 and 5, our distance has decreased. Okay, so it's like, let's say you want to go from point A to point C, and in between you have point D.
Yeah.
So when you are at A and you want to move to C, you will have to cover two distances from A to B and B to C. But if what if we were at B itself? Will you go to A again? No, it's not necessary. You can directly jump from B to C. That concept I'm using here. So it's like from B to C, I'm directly jumping. This means I'm subtracting the distance. If I have A to C distance, I'll subtract A to B. So I will get it's like okay. So I'll write it here to be to look here. If I am at A, I go to B, then I go to C. If I know the distance of A comma C is known, I covered the distance from A to B. So if I want to know distance of B to C, if I want to know distance of B to C, this distance, then it's totally useless to gather these two previous information. Okay, I will basically use those two previous information which are the parents information
Mm-hmm.
and make use of that information to get the current answer.
Perfect.
So A to C, yeah, it's basically the same thing. It's basically the same analogy here. So I'm just doing that thing instead of you know lines I have reduced it to one line here in the line number 99.
99. Yeah.
So I think this is the solution, and this will take off n time because we are using 2ds. Even though we are using 2ds's, we are essentially or visiting all the nodes only 2 times, not in
Mm-hmm.
all the iterations. So it will be O of 2n, but since 2 is a small constant factor, we can neglect it. So the time complexity, I'll write it here. This is O of n
Which
and
line you're writing it?
124.
Can you write it in line 75?
Base complexity, we'll have to see. Okay, so how many variables I have declared? If we neglect, then can I neglect this graph because we were given edges, or shall I include this also? Because we are explicitly calling. Okay, so we are explicitly declaring in what do you call this a graph. So I'll have to consider this as well.
Yes.
I'll write it here.
Yes.
O of n nodes. So we will use O of n.
Yeah.
O of n. And now this will also take. This will also take O of n. Subtree size will also take O of n space. And answer will also take O of in
you
space.
you can ignore the 117, like the answer space, because like that's an auxiliary space that you will need for sure.
Okay. So since you know 1, 2, 3, 4, so we are using of 4n. We can write it as 4. 4 is also quite a small
Yeah,
constant factor. So
it's more of
we
like
can
not even as being a small or big. It's as far as you know.
it's in middle.
Yeah, yeah, no, as far as you know that this is a constant one, you can have it anything. So because then
Yeah.
you know that this will take this much time, so you can depend upon it.
Reduce it. I think no, it's fine. Yeah. So I think this will be the optimal solution.
Okay.
So we'll have to visit all the nodes at least once. So time complexity wise, it's apologies.
So
Complexity will be O of 10. It can't be lower than that because we'll have to essentially visit all the nodes at least once. And
uh-huh.
space complexity might be able to reduce it.
Okay, so in case let's say that there was a given condition that the the value of edge is not one anymore.
Okay.
Yeah. How much of a change you think your code would have needed, and where all places you think you would have made the change? So let's say that even if you do not do the absolute changes, can you pinpoint out what are all the changes that you would have done, and you know the requirements will change according to in your code that you've written.
The code will completely change, but the concept will be kind of similar because uh, here I am taking subtract as an assuming the distance at all the edges is 1.
Yeah.
So if I use the same concept, it will be totally wrong because all the edges they are contributing a different value.
Mm-hmm.
But if you look closely, you can notice one thing that edges matter at all. Since I mentioned here that if we go from 1 to 2, going from like basically it's decreasing all the values in the subtree by -1. For all the nodes, it will be -1. So it's basically the subtree size. This means if even if the depth or the edge weight changes, we have to only change one thing, which will be line 84. It will be instead of +1, we will have to uh, weight of node. Okay, so let's say if I am given a vector of pair,
Yeah, I,
so it
J,
will
K.
be weight
So
of
yeah, the third
I
value.
node to I. Yeah, so node to I will have to mark the edge weight. So this will be the only change.
Perfect. Yeah, yeah,
Yeah, so this will be the only change.
perfect. So your code is really modular, because then it lies to a very big possibility that your next question, or in a scenario, it might not be a certain thing. So yeah, that's really really well done code. Uh, yeah, yeah. This is the question that I have for you. This was the question that I had for you today. If you have any of the questions for me, or if our viewers have any of the questions, please feel free to ask us now. Couldn't anything that you would like to ask me?
So I think I don't have any questions right now.
Okay, okay. Yeah. Any suggestions that you would say that one of the best resources that you have found so far to learn concepts of, let's say, graphs or even trees? What do you think? Or how do you actually
All this more.
understand the idea of, imagine it, or how does it comes to you?
It's like graphs and tree-based questions are more like imagining things. That's all. Because as long as you're solving more and more problems, get a hang of CSS and DSS. So I believe these two are the basic ones.
That's true.
These two can do wonders.
Yeah.
because all the other algorithms or all the other standards are made out of using these two.
That's true. Yeah.
So can't say if DFS or BFS is superior. You can also use FSCS, but since we know DFS will require a lot of code, and the code won't be so modular, and
Hmm.
it will be more confusing. So I used DFS here.
Okay.
Also use BFS.
So,
Just a matter of practice.
okay. Tell me this: when do we usually opt for DFS versus when do we opt for BFS? Any of the specific
Okay.
patterns?
So like there is a thumb rule. Okay. Like if you are willing to find a distance or there is a question related to distance, then DFS won't be able to find it. Well, in tree it's totally different. In tree, yeah, you will be able to find it, but in like since I showed you here, that will be plus one here in line number 84. But in let's say if we have a graph, then we won't be able to find the shortest distance or the correct distance at any node because we might have multiple edges. And what DFS does is, instead of finding all the paths, it finds only one path.
Yes.
If it were to find all the paths, the time complexity would go exponentially high based on traversal the DFS because we are exploring all the paths.
Yes.
And here comes to our rescue the technique called BFS because we are pushing everything into the queue. So at every node, we will have to see all the paths. So it's not like DFS. So it will take only O of n instead. So DFS will take exponential and BFS will take only O of n. So this is one of the case. And whenever we want to visualize a solution recursively, finding answers for all the nodes when like for finding answer for all the things or all the indices when we have answer for one
Yeah.
and we can calculate answer for one, then it gives us a hint of using recursion based approach.
That's true. Like
So that's why DFS.
you start with recursion, and then with recursion you build on top of it the DFS, and then same thing, you use the same concept to build DP out of it as well, right?
Mhm.
Yeah. Perfect. So
So like it's not making much use of DP. It's like basically DP is mm, too much of a fancy word because we aren't doing any kind of well it can be called a DP because we are using the previous value, but yeah, I think this is basically a DFS approach only. DFS, that's all.
no, I was talking like in general about recursion does
Oh yeah,
lays
yeah,
your
yeah,
foundation for all of these concepts, and once you
yeah,
are
exactly.
able to visualize the data structure, it's a piece of cake from there.
Yeah, exactly. We're just saving value and reusing it again and again.
Yes. Okay. Cool. Yeah, this was the question for you. I believe like this was kind of on a, oh, you can expect one question like this in one interview, and you did pretty well. Your code was very modular, and your explanation as well. So kudos for that. Yeah. And since okay, this was all the discussion that we have for this one. Please feel free to point out any of the questions. We'll be posting out this code and the links of the resources in our repository. You can check that in the description. Yeah, and then Mukund, if you don't have anything, we can sum it up, or any things you want to say to the viewers, feel free to do it now.
I'd like to mention only one thing. Like this is a very famous technique called tree rerouting DP. So it's like whenever we see, there's a hint for all these kind of questions. Whenever we get something like calculate for all the nodes, it directly gives us a hint that we have to use this technique because we are essentially iterating through all the nodes. So it will in brute force manner it will take n square, but the rerouting comes to help and it takes us work and time.
Yeah.
It is very popular in competitive coding. There have been a lot of questions on code forces also rated 1900 and 2000 in yellow or the candidate master zone.
Yeah.
It's very famous. Those questions are actually very tough. This one was one of the basic ones.
Yeah, so what actually happens is that as the questions that are being asked inside the interview, they become more and more popular. uh, so the interviews inside the questions inside the interview are taken a little bit hint from, let's say, the competitive coding ones, and then they are introduced as the new questions inside the interviews that is being asked. So it's a really good tip, like that, say that in the cases of whatever that is happening, if you do want to keep a little bit on your toes, it's always good to have a hang of always solving out the questions, or at least getting familiar with few of the new techniques which are always there. As we see that initially it was used to be a very simple questions that were being asked inside the companies. Now they're moving towards more questions which are related to trees and graphs. So that is a good thing to stay on top, and then taking some hints from the competitive codings as well, right?
Yeah, but I think I like to add one more thing.
Yeah.
Like if like too much of competitive programming is not necessary though. I mean, few hard questions on Leetcode will work because CP will take a lot of your time, and also those tough questions requires the interviewer to study as well. So as I know, company people don't have that much time to invest in data structures, so they won't be asking too difficult.
Exactly.
Maybe this will be the like this will be the topest the topmost difficult question which you might be able to get, or some based on this concept.
Yeah.
So yeah, for tree routing technique, at least this will be the toughest problem. They won't go any further from here because
That is true,
all those will be very, very difficult.
because like in an interview you have a specific session, a time constraint that you do need to work it on. Also, like in an interview it is more focused upon how do you write the code and the explanation that you have, but the insights of the coming of the new questions that can come into the market can be taken a little bit in the competitive programming. And not saying that you don't need to religiously follow it, but just keep an eye. Yeah.
Exactly.
Cool. Perfect. So this was it. Thank you so much everyone for this stream. Everyone who was live now and everyone who will be watching out the video. We'll be seeing you soon in the next one next week. And please feel free to ask us any of the questions that you would like us to include in the interview sessions, or it can be of interview, I mean DSA, or it can be system designs as well, and we'll be taking that into consideration as well. Sure. So till next time, and thank you everyone. Please do subscribe out the channel and share it in your community so that this community does increases and reach the right person that needs to watch it. So, see you everyone. Come on man, say bye.
Yeah. Bye.